first thing we're going to talk about is something called arc length and sectors in circles. So arc length is the distance between two radii along a section of a curve. So if you have a circle and you have two radii, the arc length is the distance between those on the outside. So basically, arc length is a fraction of the circumference of a circle. So the formula is S equals r theta, where r is your radius, and theta is your central angle for your arc in radians. Next, we have area of a sector. So it's a region enclosed by two radii of a circle and the arc. So similarly, if I have my circle and I have my two radii, the sector is now the space enclosed. So it's a portion of the area of a circle. So the formula, area of a sector, is theta over 360 times pi r squared. So theta is your central angle, and for this formula, theta is in degrees. And then r is the radius. So we've got our pi r squared, which is the formula for an area of a circle, times theta over 360. So you can figure out what fraction of the circle I have an area for. Let's do some examples. So a circle has a radius of 3. An arc in the circle has a central angle of 340 degrees. What is the length of the arc? So I have my circle. I have a radius of 3. And then 340 degrees is my central angle. So we're trying to find the arc along this piece. My first step is going to be to convert my angle to radians, because for arc length, my central angle has to be in radians. So I'm going to do 340 times pi over 180. So I'm going to leave pi in my answer, and then I'm going to simplify the 340 over 180. And we're going to have 17 pi over 9. So for my arc length, I'm going to have 3 times 17 pi over 9. Now 3 and 9 I can simplify. So it's going to be 17 pi over 3. So a circle with a radius of 1 has an arc with a 20-degree central angle. What is the length of the arc? So I have my radius of 1, my angle of 20. So I have to do 20 times pi over 180. And and we're going to get pi over 9. So we're going to have 1 times pi over 9, which is just pi over 9. We could also work backwards. So we have, so one more example, sorry. Circle with a radius of 8 has a central angle that measures 3 radians. What is the length of the arc? So 8 centimeters, 3 radians. So I don't have to do any converting here. So I just do 8 times 3, and I'm going to get 24 centimeters. So this time I have units for my radius, I'm going to have units for my answer. Okay. So we can also work backwards. So I have a circle with a radius of 4 and an arc length of 6 centimeters. What is the measure of the central angle? So this time, I have 4 centimeters. We know the distance along the curve is 6 centimeters. And we're like, okay, so what is our angle theta? So use my formula. S equals r theta. I now know S is 6. I know r is 4. I don't know theta, so I'm just going to divide by 4. And we get theta is 1.5 radians. Now, if you solve for the central angle, you will always solve for the central angle in radians, because in the formula, theta is in radians. If I wanted it in degrees, I would then have to take 1.5 and multiply by 180 over pi. Which is roughly 85.9 degrees. All right, now let's look at some area of a sector. So we have a sector with a central angle of 30 degrees and a radius of 12 inches, and we want to know its area. So I'm going to do 30 over 360 times pi times my radius, 12 squared. So this time my area is likely going to be I'm going to leave it in terms of pi. So I'm going to do 30 divided by 360 times 12 squared. And that's going to give me 12 pi inches squared. If I wanted to know what that was in a decimal, I'd take 12 and I'd multiply it by pi. So it's roughly 37.7 inches squared. We could also work backwards with area of a sector. So we have an area of 49 over 3 pi millimeters squared with a radius of 7 millimeters. What is the measure of the central angle? So we have our 7. We know that this is 49 pi over 3. And we're trying to solve for theta. Okay, so use our formula. We know the area of the sector, 49 pi over 3 equals theta over 360 times pi r squared. Whoops, I know r, sorry, times 7 squared. The first thing I'm actually going to do here is cancel out the pi. So there's pi on both sides, so I'm going to get rid of the pi. So I have 49 over 3 equals, and then 7 squared is 49. So it's going to be 49 theta over 360. And now I'm going to cross multiply. So 49 times 3 it's going to give me 147 theta equals 49 times 360, which is 17,640. Then I'm going to divide by 147. And theta is 120 degrees. Now in this case, unlike with arc length, the formula that we use for the area of a sector is always in terms of degrees. So if I solve for theta, I'm solving for theta in degrees. And if I want to know its measure in radians, I would then have to take 120 and multiply it by pi over 180, which is 2 pi over 3. So last example, a sector with a central angle of 175 degrees and a radius of 12 feet. What is the area of the sector? So we have 175 over 360 times pi times 12 squared. So this is going to give me 70 pi feet squared for my area, which as a decimal is about 219.9 feet squared. Let me know if you have any questions about arc length or area of a sector for circles.